Hi, it's Mr. Wassman, and once again, we are looking at the end of the year assessment study guide that canvasses the entire span of fourth grade math from everyday math. We're on problem number 7, which has 3 parts A, B, and C. And as you can see, there is a line plot graph to create. Okay? Andreas measured the wingspans of several different butterflies to the nearest 1/8 of an inch. Below are the measurements he recorded. Plot the data on the line plot below. Use a title and label the horizontal axis. Okay, so we go back to the story problem to find the information of what this graph is going to represent. And it's the wingspan of butterflies. So the wingspan is measuring the tip, the farthest edge of one wing, like say on the left-hand side, to how far the other wing goes on the right-hand side. So that's your wingspan. Okay? And we have a number of measurements from different butterflies. So Andreas is probably trying to figure out what is the average or what is the range of the average butterfly wingspan. Okay, so what we have here are a number of measurements. So this is how we would go about plotting this out. So the first thing we would do is we would look at the number that's first represented, which is 3 7/8. Okay, now on this number line that you see, we have the number 3 written in for us, and then we have the number 4, and then we have a bunch of hash marks in between. Okay, so these hash marks represent intervals of eighths of an inch. There are 8 of them, 8 spaces between the 3 and the 4. So another way of thinking about 3 holes is 3 and no eighths. Okay, and then we get to this spot right here. That would then be regarded as 3 and 1/8, followed by 3 and 2/8, and 3 and 3/8, and I think you're starting to get the picture. Eighths of an inch. 3 and 4/8, 3 and 5/8, 3 and 6/8, 3 and 7/8. Then we get to 3 and 8/8, another way of thinking of 4, because when you have 8/8, 8/8 is the same as one whole. And a simpler way of thinking about 8/8 is one whole added to 3 wholes, that would give you 4 whole inches. And then you would wrap this up with 4 and 1/8 and 4 and 2/8. So we go about setting up our line plot graph. And as you can see, there's a 3 and 7/8, so I'm going to put my X in this box right here, and then I'm going to cross that number out. So I remember that I've already plotted it. Now I go to the next number, 3 and 1/8. That would be here. I cross that out, and I'm just going to go through the line, and every time I see a number, I'm going to put an X above that hash mark that has that measurement. Now, right here, as you can see, I have another 3 and 1/8. So that X would go above the first one. Same with this one. I have a second 3 and 2/8 measurement. I have a second 3 and 7/8 measurement. And I keep going. Forgot to cross mine out. I'll lose track if I don't do it. So now, as this graph starts to fill out, you're going to start to see some trends. Okay? You're going to see some numbers ranked measurements more than others. Okay? Now, before we go any farther, we need to title and label this line plot graph. What was Andre's measuring? Well, he was measuring the wingspans of several different butterflies. So we could write wingspans of butterflies. There we go. And then down here, the label tells us what the numbers represent, and it's inches. Okay. Now that we have our line plot graph, we can now answer some questions. What is the combined length of a wingspan measured that are greater than 3 1/8 and that are less than 3 5/8? So you're looking at our graph that is greater than, that means bigger, and less than, that means smaller than 3 5/8. So greater than 3 1/8, and then less than 3 5/8. So you're going to look at the space that is past this point here and stopping before you get here. Okay? And then number 7C asks us, what is the difference between the longest and shortest wingspan? So when you see the word difference, that tells us to subtract. So you would find the measurement on the number line that has an X over it, that is the longest, and you would find the number on the number line that has an X, that is the smallest. And then you subtract the two. And that's how you'd go about solving these problems on this page for problem 7A, B, and C. Okay, try these out, and we are going to talk again for problems 8 and beyond. Thanks.